Edwin Hubble. A star athlete in college, Hubble had won a Rhodes Scholarship and studied law at Oxford University in England. Upon returning home, however, he decides against becoming a lawyer and heads off to graduate school to take seriously a fascination with the stars that he has felt since childhood. When Hubble arrives at Mount Wilson in 1919, he's a smart but arrogant 29-year-old who has taken pains to adopt what he sees as the proper image of an astronomer.
What he tries to do is to create this portrait of himself as a kind of natural-born patrician. He tries to lose his Missouri roots because I think he's embarrassed about those things. He sees the English gentleman as being the prototype of what he wants to become. He wears English tweeds, he wears knickers, which have gone out of fashion except on the golf course. He smokes a pipe.
He spoke with an affected British accent. He had dueling scars, which were said to be self-inflicted when whispered among the staff.
He loves being separate and apart from his fellow human beings, and he plays that to the hilt.
In time, most of Hubble's personality quirks are overlooked because he's an excellent astronomer with a gift for asking the right questions. Hubble wants to unlock the secrets of the nebulae, faint, fuzzy smears of light that have puzzled astronomers for 1,000 years. Even with Hale's magnificent 100-inch, their true nature eludes him for 4 long years. Finally, in October of 1923, while photographing one of the spiral arms of the Great Nebula in Andromeda, Hubble catches a break.
He took a 40-minute photographic plate and developed it the next day and looked at it and thought he saw what was then known as a nova. That was another hot topic. That is, what were novae, what were stars that brightened unexpectedly. So his curiosity piqued. He decided the next night, which was a better night, to take another exposure and took a deeper photographic plate.
This plate has what he believes are 3 novae, yet an even greater surprise awaits him.
Well, when he got down to the mountain the next day and he began to compare the plates with those that had been taken earlier, he discovered that one of the 3 novae was not in fact a nova, but it was a Cepheid, and it's a eureka moment. He writes in capital letters on the slide itself, VAR, exclamation point, for variable star.
Hubble knows instantly, thanks to Henrietta Leavitt's discovery about Cepheids, that this star and the system it's a part of must be very far away, and the universe must be far larger than anyone had dreamed.
Yeah, it must have been a good moment for him. What he found was that the distance to M31, the Andromeda galaxy, one of, turns out, our nearest neighbors, is about 2 million light years. So people had been talking about the scale of our galaxy, 10,000, 20,000, 30,000, maybe 100,000 light years. What this meant was that M31 and all those other galaxies were not part of our system. They were themselves big systems equal to the Milky Way.
There are, in fact, billions of galaxies, each one containing hundreds of billions of stars. Hubble's discovery of the stunning size of the universe and the multitude of stars and star systems that can be found within it changes forever our picture of the cosmos. That discovery alone would have made Hubble one of the great astronomers of the century. But he continues to study distant galaxies and makes an even greater discovery. For 5 years, he gathers data on the movements of galaxies, recording where they're headed and how fast. If a galaxy is moving away, its light is stretched. The interval between wave crests gets longer. The light appears redder. The faster it's moving, the redder the light. If a galaxy is moving closer, the light is compressed and appears bluer.
After many years, Hubble could sit down and look at this great quantity of information, and he plotted a chart. He plotted for the nebulae the motions against the distances, and he found something truly amazing, a straight line.
He found that the distance of a galaxy is proportional to its velocity. So as you go twice as far out, turns out the velocity is twice as big. You go 3 times as far out, the velocity is 3 times as big. We live in a world, I mean, a big world, and a universe where everything's rushing apart, and it's happening in a way we call Hubble's law, where the velocity is proportional to the distance.
An expanding universe. How could that be when the whole history of human thought just took for granted that the universe is this fixed thing, and how could it change? The universe is everything. How could it have an evolutionary path? Because if you had an expanding universe, that might mean it had a beginning. It might mean it'll end. This is a discovery for the ages.
Before Edwin Hubble's discovery, even the great physicist Albert Einstein assumed that the universe is fixed and eternal. His original equations for general relativity had predicted a changing cosmos, but Einstein was unable to believe his own theory. So he added what he called a cosmological constant to bring the universe to rest. Years later, in 1931, Einstein travels to Mount Wilson to meet Hubble. While there, Einstein declares that his cosmological constant is the greatest blunder of his scientific career. Of course, by this time, Einstein can afford to admit to a mistake or two. He's already renowned as one of history's greatest scientists, the man who redefines gravity, space, and even time.